Okay, so for this one always ends up causing people problems. We've got let u of 2 equals 7, v of 2 equals negative 3, u prime of 2 equals negative 9, and v prime of 2 is equal to 6, and we want to evaluate some derivatives that I haven't listed yet. What's going on here is we have two different functions. We have u of x and we have v of x. It could be anything. We could have f of x and g of x. We could have a of x and b of x, whatever. We decided to go with a u and a v here. So we have two functions that we don't know what they are. I have no idea what u of x is. U of x could be the equation 3x squared minus 8x plus 2. I don't know what it is. But I do know that if I plug 2 into the u function, somebody did that work for me, we got a y value of 7. Somebody also did the work of plugging 2 into a different function, v of x. I don't know what it is. It could be the cosine of x plus 19. I don't know. But I know that if I plug 2 into the v function, I'm going to get negative 3. Also, the work that somebody else did, they went ahead and took the derivative of that u function that I have no idea what it is, and they calculated that the derivative evaluated at 2 is equal to negative 9. Likewise, the derivative of my v function, if we plug in 2, is equal to positive 6. So I don't know what these individual functions are, but I know at least a little bit of information about what's going on at x equals 2. Based on that, I can evaluate certain derivatives. For example, let's find the derivative of 3 times our u function minus 2 times our v function. So to do that, I'm going to have to take the derivative of 3 times whatever the u function is minus 2 times whatever the v function is. Applying the rules that we have learned, I know 3 is a constant multiple, and so 3 is a constant multiple means I'm still going to have a 3. The constant multiple rule says that 3 is going to multiply the derivative of your u function. I don't know what my u function is, and so I'm going to call that u prime. Negative 2 is also a constant multiple. That's going to stay there. That's going to multiply the derivative of my v function. I don't know what my v function is, and so I'm going to list that as v prime. Now, this is all I can do if this is all the information that I'm asked for. Find the derivative of 3u minus 2v. It's 3 times u prime minus 2 times v prime. If I want to evaluate this derivative at a certain x value, we can write that one of two ways. I could write it as at x equals 2, or instead of writing it in that way, what I can do is just after that derivative, in parentheses, I can put a 2. That way can be misleading. It looks like I have to distribute the 2, and so I'm going to go back to the original way that I wrote it, at x equals 2. Just understand that that can be presented in many different ways. But we're only going to be able to get a value if we know the x value, because we only have information about our x value, specifically at x equals 2. So now that I have the derivative, I can evaluate this thing at 2, which will give me a slope. So instead of calling it dy dx, I'm getting a specific number. I'm getting a specific slope at a specific point. So I'm going to call it m now. M is going to equal 3 times whatever u prime is evaluated at at positive 2, and u prime evaluated at positive 2, what it says up at the top, is negative 9. Minus 2 times whatever v prime is evaluated at 2, and again up at the top it says v prime of positive 2 is 6. So we have m is equal to 3 times negative 9 minus 2 times 6. That's easy to evaluate. 3 times negative 9 is negative 27. Negative 2 times 6 is negative 12. And when I put those together, I get negative 35. So the slope at 2 for this new function that I created, 3 times whatever the u function is minus 2 times whatever the v function is negative 35. I didn't have to take any derivatives of the individual functions u and v. I just had to take the derivative of my new function, 3u minus 2v, and then I utilized the information that was given to me in order to come up with that slope at that point. Now, we can take other derivatives as well. Instead of having the derivative of 3u minus 2v, maybe we want the derivative of a different function. Maybe u times v. And again, we need a specific point to evaluate that at. We'll evaluate that at x is equal to 2. So first, I have to do the derivative of u times v. Well, that looks like a product, so I'm going to use the product rule. So the derivative of u times v is going to be my u function times the derivative of my v function plus my v function times the derivative of my u function. Remember, order doesn't matter for the product rule, so if you said, hey, I wanted to do v times u prime first, great. It doesn't matter. It is product rule. It's adding, it's multiplying. Adding and multiplying, order doesn't matter. Now, this is all I can do if I don't know a specific x value, but we do. We want the x value at 2. So I go up to the top, and I take a look at what the y value is for u when x is 2. It says u of 2 is 7, and so 7. Times v prime of 2. I jump up there, and I see that v prime of 2 is 6. Plus v of 2. v of 2 is negative 3. Times u prime evaluated at 2. u prime evaluated at 2 is negative 9. So simply taking somebody else's work, they did all the derivatives and evaluated them at 2, allows me to take the derivative of this new function, u times v, and so then it's just work it out. 7 times 6 is 42, plus negative 3 times negative 9 is positive 27, and so that works out to be a slope of 69. No problem at all. These derivatives are easy because we're simply using work that somebody else did, u of 2, v of 2, u prime of 2, v prime of 2, along with what we know about derivatives, taking the derivative of a product, taking the derivative of a quotient, taking the derivative of a constant multiple, all of that stuff. Now, we're going to do one more. We're going to do a quotient rule, but I don't have the space, so I need to get rid of all of this other work that I did. And there it goes, all my pretty work. Thankfully, you have a rewind button on your computer, so if you need to go back and see that, you can just hit that rewind button on the YouTube here and easily see the stuff again. So we're going to do one more derivative. We're going to do the derivative of, let's change it up. Let's go the derivative of v over u. And again, we'll evaluate this at 2. So first, we have to take the derivative of v divided by u. That's the quotient rule. It shouldn't matter what letters are there. We did g's and k's in class. It does not matter at all as long as you get the proper order. So the proper order is the denominator function, which is u, gets multiplied by the derivative of the numerator function, so that's u times v prime, minus my numerator function, v, times my derivative of my denominator function, which will be u prime, and all of that will be over my function u squared. That's all I can do if I don't have any information up top in the directions about what's going on at 2. But I do. I know what all of these values are at 2 and only at 2. If this problem asked me to find the derivative at x equals 7, I couldn't do it. I don't have that information because I don't have the functions and nobody gave me the information of what's going on at u of 7, v of 7, etc., etc. So we can only do this for x equals 2. And so we just plug in u of 2 is 7 times v prime evaluated at 2 is 6 minus v of 2. v of 2 is negative 3 times u prime evaluated at 2, which is negative 9. And all of that is over u of 2 squared. u of 2 is 7, so all of that is over 7 squared. Now it's just evaluate. So 7 times 6 is 42. Minus a negative 3 times a negative 9 is positive 27, so we have minus 27, all over 7 squared, which is 49. And so then we just need to subtract 42 minus 27, which is 15, over 49. That does not reduce. And so there is the derivative evaluated at x equals 2 for the function v of x divided by u of x at the coordinate x equals 2.